Okay, well, let's take a look at part B here and see if we can figure out what's going on. In part B, we're going to write the method evaluate light, which computes and returns the status of a light at a given row and column based on the following rules. Okay, so we're going to be returning the status of a light, which may or may not align with what the actual light itself. We'll have to see. If the light is on, that means if the light is true, return false if the number of lights in its column that are on is even, including the current light. Okay, so it looks like they're trying to be kind of tricky here. They're trying to mess me around with some logic here. I'm not sure why you would do this. This looks like just one of those exercises where they're trying to figure out if you could figure out what the logic is. If the light is off, in other words, if it's false, we're actually going to return true if the number of lights in its column that are on is divisible by 3. So in one case, I'm looking for things that are even, an even count. In another case, I'm looking for a divisible by 3 count. This is kind of crazy. But otherwise, if it's not one of those weird things, then I'm just going to return the light's current status. Okay, so based on that, I could probably figure out what's going on, and I could jump through and start trying to code this. But another thing that's really nice about these problems that you'll be given is, again, it's not going to be more than 10, 15 lines of code max, but they want to make sure you really understand what's going on. So in addition to this brief problem statement, they'll say things like, for example, and then they'll take you through this long, detailed example, which is wonderful, really allows you to make sure you understand what's going on. So suppose that we have a LightBoard sim, which is equal to a new LightBoard. And so there's 7 rows and 5 columns. So here's the 7 rows, 0 to 6, and the 5 columns, 0 to 4. And we've got an initial state where true represents on and false represents off. Lights that are off are shaded. Oh, that's so nice of them. And then what I'm looking at down here is they say, well, here's some sample calls. Okay, let me take a look at that and see if I can make sure I understand exactly what's happening here. So for instance, if we call sim and say, let's evaluate the light at 0, 3. Well, the light at 0, 3 is going to be, that's row 0 and column 3, which is this one here, which is true. And we're going to return false. And why would that be? Because this light is true, the light is on, and the number of lights that are on in its column is even. And is that correct? 1, 2, 3, 4. The number of lights in this column that are on is even. And that was something that they had said right at the start there. If it's on, return false if the number of lights in its column is even. Okay, so it looks like, yeah, I'm going to be counting lights. Regardless, I'm going to need to be counting these lights. Number of lights in that column, number of lights in that column. So I'm going to need to be counting lights in columns regardless. Let me double check a couple of these other ones. Evaluate light 6, 0. And this, again, I don't want to belabor the point, but you should take the time. Don't just jump into writing the code. Take the time to read through this while you're taking the test and make sure that you have a good understanding of the problem. That's why they've included this stuff in here, to help clarify that for you. So if I take a look at this and evaluate light 6, 0, that's row 6, column 0, that's this guy right here. And that's going to be true because this is false, the light is off, but the number of lights that are on in its column is divisible by 3. 1, 2, 3, 4, 5, 6. Oh yeah, if I count all those up, I've got a total of 6, and that's evenly divisible by 3. But 4, 1, that's row 4, column 1, that's true. I'm going to return, did I mess that up? Row 4, oh, sorry, column 1 there. That's false, and I'm going to return false because the number of lights in this column are not, that number is not evenly divisible by 3. Got it. And in 5, 4, here's row 5, column 4. That's true. 1, 2, 3, 4, 5. Because that's true and this number of lights here is not evenly divisible, is not an even number, I'm going to return the actual value there. Oh, so tricky. So tricky. Well, I'm going to be able to figure all this out, I think, without too much difficulty. I'm just going to have to keep in mind those rules up here, and I'll probably come back up to those rules and check on them at some point. In the meantime, more niceties here. The College Board has said, here's class information for this question, just in case you were wondering. The name of the class is LightBoard. The name of your instance variable is lights. We're going to have number rows, number columns. Got it. That's how we started this thing. And we're going to be evaluating a light based on its row and its column. So now with all that in mind, let's go ahead and glance at this Java doc here, remind you of what's going on, and then let's write this method that's going to implement what they've asked us to do. So here's just a blank area, and we're going to go ahead and start writing. I'll go ahead and begin with curly braces there. And as I'm trying to figure out what I want to do, as I'm trying to figure out how I'm going to implement this logic here, which seems a little bit tangled to me at the start here, one of the things that's common in all of these is I'm going to need to know what the current state of the light is. So that's going to be something I'll be trying to keep track of. I'm also going to need to know how many lights are on in each column. They're asking me to do that. So because that's going to be happening regardless, I think I'm going to count up the lights that are on in a column first. So let me go ahead and do that. I'll take care of that and see what's happening. If I don't do that here, then I'm going to have to do it later on, and then it's going to have to be, I'll probably have to write that code twice. So let me count the lights that are on in each column. And I'll just kind of, maybe I'll just write a little example for myself here, just to remind myself. Yeah, I've got some rows and columns here. These are my rows going down. I'm going to have a light, say, right here, and I'm going to need to count up all the lights that are in that column. Okay. So how do I do that? I'm going to need a counter. I know I need a counter, so we'll call it call count. Start that out as 0. And then I'll go through every light in that column. So my row is going to be changing, but my column will remain the same. So my row is going to run from 0 all the way to the number of rows. So for int r starting out at 0, and then I'll have r keep on going as long as I'm less than, remember how you know the number of rows in a table, right? That's going to be the lights dot length, where that represents the length, no parentheses there, the length of that table there. And then the columns would be the lights 0 dot length. But here I'm just looking for the number of rows. So good, I'll do an r++. This is going to run through every row in there. And if I find a light that's on, I'm going to add a number to my call count. So if lights row, and then this is column, a little tricky there, r for my loop there, and column, if that's equal to true, and I could write it this way, but remember, if true is equal to true, I could just write it as just a little bit of a shortcut here. I could say if that's true, then I'm going to add 1 to my column counter, and maybe I'll just do that over here, call count ++. And if I don't have an on there, then I'm obviously not going to add to it. So by the time I get done with this, I'm going to have a count of how many lights are on in that column. And I'm going to need that for the logic that I'm pursuing next. Okay, feel pretty good so far. Let's see what's happening next. Now I need to double check that logic. If the light is on, now this is a little bit tricky. So I'm going to check to see if the light's on, and I'm going to return, sometimes I'm going to return true. If the light is on, I might return the light's current status, but in this case, I'm going to be returning false if I've got that even number here. So I've actually got 2 things I'm checking on. If the light is on, and checking the number of lights in the column. So there's a couple ways that you could do this. One way that you could do this is you could put those into a compound statement, and I could say if the light is on, so if lights row, because that's row, column, if that's on, and I've got this even thing going on, then I'm going to do something. But my problem is I've got two things that I need to check on. So first of all, I need to check to see if that's on. So I think I'm going to first of all check that. And that says if this is on, and then I'll check to see if I've got an even count. So if that's on, and next then if call count is evenly divisible by 2. If that's an even number there, if that's the case, then I'm going to return false. But if that's not the case, else I'm going to return true. So that's going to take care of what happens if I've got a light that's turned on. So I'm breaking it up, I'm breaking those conditions. If it's on and if it's evenly divisible by 0, I'm breaking that up into two separate parts here. The else part for this, this if statement here, because I've nested ifs, the else part for this is, well, what's happening if the current light is off? And I've got those other conditions that I need to think about. Let's go back up and take a look at those real quickly. What happens if the light is off? If it's off, I'm going to return true if the number of lights is divisible by 3. Oh, very tricky. They're trying to change things up on me. Okay, so else, I already know that it's off. So now I just have my if statement here that says if, and how do I say if something's evenly divisible by 3? If column count divided by 3 is equal to 0. If that's evenly divisible, then I'm going to return true. But if it's not evenly divisible by 3, else I'm going to return false. And I'm pretty happy with that logic right there. I think that's pretty solid. Now, one of the nice things, I haven't taken up all my time here, one of the nice things you can then do, and I recommend you do this, if you have a little bit of time left over, what you can do is you can say, okay, let me just follow through step by step this evaluate light or this 4, 1. Let me run through and check and make sure that the logic that I've implemented here returns the correct value here. It's a great way of checking your work to make sure that you've done the right thing there. Otherwise, great solution to the last problem on the 2019 AP Computer Science A exam.